Our Pollitt and Beck research book explained how a meta-analysis depends on calculating a measurement that expresses the relationship between the variables in each study. In this study, the calculated relationship is between maternal depression and their child's cognitive development. But because effects are captured differently, depending on the variable's level of measurement, there is no single formula for calculating an effect size. The most common scenario in nursing is to compare two different groups on the same continuous outcome. You would think this is actually where my study fits, one group being women with maternal depressive symptoms and one group without, on the same continuous outcome of child function. However, they couldn't do this because even though they are measuring the same thing, different scales were used. This is why Cohen's d is needed. Meta-analysis software was used to convert estimates of effect sizes to a common metric of Cohen's d to represent the difference between two group means divided by the pooled standard deviation. Here is a forest plot to illustrate how the meta-analysis from the 14 studies showed some statistical significant relationships between maternal depressive symptoms and child cognitive development. Children whose mothers had high depressive symptoms were 0.25 standard deviation lower than that for children whose mothers had few or no depressive symptoms. I would like to report that I may be biased because I am convicted that integrating screening for maternal depression within the context of pediatric care may help to identify and treat women and children at risk. Thank you and good night.
Good night.